Hi, I'm Dr. Colin Campbell. I'm a senior research scientist here at Meter Group, and today we're going to be talking about water potential. So we're going to talk for a moment about how to install sensors. You notice here that in this diagram, the sensor is installed at 45 degrees. Why do we do that? Well, it's really to avoid preferential flow of water down into the soil and onto your sensor, your measurement area. This has happened to me. I'm measuring down at 50 centimeters or 100 centimeters. I've got a sensor up at 10 centimeters. We get a rain. Nothing happens at the 10 centimeter sensor, but I see a lot of water at the 50 centimeter sensor. Why is that? Well, you've got preferential flow, and that most often happens when we've installed these vertically. One of the cool things about the Terrace 22 is that you can actually attach a PVC pipe to the sensor, and especially if you're going to do that and leave it hanging out on the surface, you don't want that water just moving down that pipe to your sensor. So 45 degrees should help you with that. Now, what are some other things you ought to be paying attention to as you install your sensor? One of the things we tell you to do as you're installing it is to make sure to put soil in each one of these holes around the ceramic. Press wet soil in there and then press the sensor down into wet soil at the bottom of your hole. As you do this, we get great soil, the native soil, to your wet soil contact because we want to have the water transfer in the liquid form and not the vapor form. If you got cracks around your sensor, then it will take a really long time to equilibrate. So just be aware of that. Sometimes people argue, hey, you're not going in an undisturbed soil. Well, with the water content sensor, it does matter. You need to go into undisturbed soil. But with a water potential sensor, because they're measuring the energy state of water, which tends to equilibrium in a system, you don't have to be in undisturbed soil. That water will just equilibrate between the native soil and the ceramic, and then we can measure the water potential. We designed the Terrace 22 to be different from the Terrace 21, the ultimate installable sensor. And to do that, we used an electrician's drill to be able to get deep into the soil so that we can drill a hole and then slide that sensor right down into the bottom of that hole. And if you ever needed to take the sensor out, we made it so you could stick a piece of PVC pipe on the end of that sensor and just pull it out. Now remember, as I just said, we want to make sure that no water gets down into that hole once we've got those installed, so we go in at 45 degrees. Then we take a drill out in the field, drill a hole, and in pops our sensor. Now, it's not uncommon once you've installed your sensors into the field to ask a really important question. What do these numbers mean? And I'm not going to be able to tell you everything about those numbers here in this short primer on water potential. If you want to know, head over to metergroup.com into our knowledge base and look one of those virtual seminars up that'll tell you all about water potential. We'll show you the data and see what our experiments show when we put these out in the field. So can I tell you what the numbers mean? Well, not yet, but I think you can figure it out. One other question people often ask is, my sensor is responding a lot slower than it should. One of the most typical reasons that we don't get the response we think we should is because we've left air gaps around the sensor. As I told you, when you install it, you need to fill all these gaps with soil. If you haven't done that or adequately connected the soil that's in those gaps to the soil around the sensor, to the soil that's undisturbed around the soil that you wetted up, you're likely to get an air gap. If there are air gaps, it turns out that the liquid water that we want flowing between the sensor and the soil stops, and we only equilibrate in the vapor phase. And it takes a long time for water to equilibrate in the vapor phase. So your sensor will often just look like a flat line going along, and you'll wonder, why is it doing anything? Or why is it just slowly trending down? And that is because you're not equilibrating in the liquid phase, you're equilibrating in the vapor phase. Another question we get commonly is that the sensor is just stuck near a 0 kPa. Why would it sit there and read near a 0 kPa? Well, we don't know all there is to know about our soil system that we're working in. And often what's happening there is your soil is wetter than you think it is. Maybe you've got a sand, and sand water is often freely available, and maybe it's so available that your water potential sensor is just not sensing much stress at all. So it's something to think about. I worked in a turf grass system for a very long time that was irrigated really well, and the water potentials never changed from negative 0.5 kPa, the maximum reading on the sensor. If you want to talk more about installing sensors in the field, I suggest you go over to our other video, the water content video, and watch that for a little while. We've got some great discussions in there on how to install sensors and what to think about when going out in the field. I've enjoyed talking to you today about water potential, but I acknowledge we only scratched the surface. If you want to know more, like I said, head over to metergroup.com, look through our knowledge base. There's so many good virtual seminars over there that will help you understand water potential better.